This is section 12.4, and we're going to talk about derivatives of exponential functions. So the first two rules that we have, when you're taking the derivative of e to the x, the derivative is simply e to the x. That's an easy one. If you have derivative of e to the u, that means anything other than plain old x. It could be 5x, it could be x squared, whatever. It's not a plain x. Then it's e to the u, whatever the original was, times u prime. So we'll see how that works. Let's look at a couple of examples. So y equals e to the 5x. We don't use this rule because that's a different than just plain old x. So we have to write it out, and I would write like a road map. E to the 5x, that's the original, times the derivative of 5x. Okay, that's u prime. So that's e to the 5x times, what's the derivative of this? 5. So the answer would be 5e to the 5x. Y equals 10e to the 3x squared. Again, we're using e to the u. So it's the original times the derivative of the exponent, the 3x squared. So we have 10e to the 3x squared times, derivative of this is 6x. Then you can multiply the 6x times the 10, you get 60x e to the 3x squared. We have two other rules. Those are both for the number e, that's specific. For every other number in the world, that's a, so that could be any number in the world other than e, you have derivative of a to the x is ln, natural log of a, times a to the x, which is the original. If it's a to the u, that's anything other than plain old x. You have the same thing, natural log of a times a to the u, but you also multiply by u prime, whatever that is there. All right, so here's an example. S equals 3 to the t. So 3 is not the number e, it's a plain old number. So we have S prime is ln 3, we're using this rule, times the original 3 to the t. Now, if we have this, S equals 8 times 10 to the 1 over t. Okay, so we've got 8 times ln 10 times the original 10 to the 1 over t times the derivative of 1 over t. And you want to think of or rewrite that 1 over t to the negative 1. All right, the derivative of t to the negative 1, the negative 1 comes to the front. That now drops to negative 2. So here's my derivative of this exponent. So again, I've got 8 ln 10, the original 10 to the 1 over t, times the derivative of that exponent, which is negative t to the negative 2. Now, this negative 1 here can multiply to the front. So we've got negative 8 ln 10, 10 to the 1 over t. Now what happened to this? We have a negative exponent. So it goes to the bottom and that negative 2 becomes positive 2. So a lot of cleanup there. This one, as long as you have the rule down, you're just plugging in, and then you have some algebra sometimes to clean up. Let's go look at the problems. All right, we've got 6 problems. Let's look at those. Y equals e to the negative 10x. That's not a plain x, so we write the original and then have to multiply by the derivative of this exponent. So derivative of the exponent. This derivative is just negative 10. So we've got the original times negative 10. The negative 10 should go to the front, e to the negative 10x. Number 2, negative 4 e to the negative 2x. So you write the original times the derivative of negative 2x. That derivative, which I'll just put that in our yellow. We should have had that here too. Okay. So the derivative of that is negative 2. then negative 2 times negative 4 is a positive 8 e to the negative 2x. Y equals e to the x to the fourth. So write your original times the derivative of x to the fourth. So again, this, in our roadmap, that's where we got to take another derivative. So the derivative of x to the fourth is 4x cubed, and then you've got e to the x to the fourth there. And that should be your answer. These really are pretty quick, most of them. Number 4, y equals x cubed times e to the x. We have to note that this is a product. So when we get ready to start, we're going to write our roadmap. First times derivative of the second plus second times derivative of the first. That's all we did, write the roadmap. Then we're going to take the two derivatives. So the derivative of e to the x is just e to the x. The derivative of x cubed is 3x squared. We multiply both of those together, and that can be your answer. Now, they might have you factor out the e to the x, but I think they'll take this answer just like this. All right, number 5. Let's look at number 5. All right, so number 5, here's our function, and we have to note that this is a quotient. This is one function of x, this is another function of x. So our roadmap is the bottom times derivative of the top minus the top times derivative of the bottom. Remember, I put this last part in brackets all over the bottom squared. All right, so in this line, I'm going to take the derivative of this piece. So that's negative 4e to the 2x times the derivative of 2x, which is 2, minus negative 4e to the 2x, the derivative of this is 9. So I've just taken, in that line, I just took the derivatives. Now here I'm doing some multiplying and cleaning up. So this just changed to negative 8e to the 2x. This changed to negative 36e to the 2x. So that's all I did was multiply there, multiply there. This is still a minus. So that turns that into a positive. And here I went ahead and distributed this negative 8e to the 2x. If you multiply it by 9x, you get this. Multiply it by 2, you get this. And you have plus 36e to the 2x over 9x plus 2 squared. Now the only thing that I did there was combine some like terms. These two are the same type of terms. So that's negative 16 of those plus 36 of those. That becomes 20e to the 2x. Still had that, and then over this. So that should be the answer to number 5. Let's look at 6, which should be our last one. So we've got this to the 6th power. So when we take the derivative, we've got to do the chain rule. So 6 times this to the 5th times the derivative of this. So that's our roadmap. And the only place we have to now take another derivative, other than the roadmap part, is there. So here I've just written that again, plus now I've got the derivative of 2z is 2. Now here I've got the original, e to the negative z squared, times the derivative of negative z squared. So I have another little derivative there. All right, now still got this over here, got 2 plus e to the negative z squared. The derivative of this is negative 2z. So I've got that. Now, if I take a 2 out, if I factor out 2, I am left with 1. And then I have this minus goes with this. So I'm left with minus z e to the negative z squared. See, these are multiplied together, and I factored out the 2. Then this is all multiplied, so I can multiply the 2 and the 6 because they're just plain numbers. And then I have this to the 5th and this last piece. So it looks a lot of confusion, but if you just take it by steps and do each piece, you should be good for the 12.4.